Hello and welcome to Grammar Development with LFG and XLE. Last time we looked at verbal complements, comp and ex-comp, finite complements, which are the comps, subject versus object control verbs, and we learned how to write control equations in lexical entries. And we also continued practicing with regression testing and debugging. This time, session 9, we will look at something called functional uncertainty. And functional uncertainty in LFG is used to model long-distance dependencies, as they are known, and I'll show you an example of that. What you do in long-distance dependencies is you define a functional uncertainty path, and we'll look at, for example, if you topicalize something, we'll look at that for English. And then you can resolve the long-distance dependency. Since we're doing functional uncertainty, I will also introduce something called inside-out functional uncertainty to you. You will not be practicing with this in the exercise. You will be practicing with functional uncertainty in the exercise, but not with inside-out functional uncertainty. What this is used for generally is anaphora and something that's called constructive case, and I'll show you an example of that. And constructive case is implemented in the Urdu program grammar. But again, it's a fairly difficult thing to do, so you will not be practicing with that in this session. I'll just show you how to do it. And finally, I will introduce to you the shuffle operator, which is how you can deal with free word order phenomena within LFG XLE. Before we dive right in, I want to say something organizational. So at this point, you will practice with two of the topics that I'm introducing here, functional uncertainty and the shuffle operator. You will not practice with inside-out functional uncertainty. We are now in session 9 and we're getting to be quite advanced. Session 10 will be the last session, and in session 10 I will show you various other things you can do with XLE, but I will not be asking you to practice with them. They get a bit too complicated to deal with within our toy grammars. So from here on, it's getting to be a bit more sophisticated. So to start up with the first topic, long-distance dependencies, what this term encompasses are situations in which arguments are not found in the clausal domain of the verb that subcategorizes for them. So to take a very simple example, something like Kim likes hoppers. If you don't know what hoppers are, they're a speciality you get in Sri Lanka. A noodle type thing you can eat. So the normal English sentence would be something like Kim likes hoppers, where hoppers is the object of like and Kim is the subject of like. But you can also topicalize, and in general in languages tend to allow you to extract items from their clausal domain. And then the question is, how do you reconstruct that in a sense? Other theories do this via movement. So they say hoppers moved from the verb place over here to the topicalization place over here. And then you have theories about that. LFG doesn't do that. LFG asks, there's this thing here, and I assume it's got a grammatical function. I wonder who it belongs to, and then it tries to reconstruct the path from where the long-distance dependency path to where it comes from. So in this case, it's the object. It's a simple object. If we look at the next example, hoppers Kim wants Sandy to like. What we have here is an ex-comp, an embedded ex-comp. And the hoppers is again the object of like. And in this case, it's a long-distance dependency because hoppers is all the way over here. But it's actually the object of like, which is embedded under an ex-comp. And you can make many, many more such examples. Hoppers, Kim thinks that Sandy likes. Here it's coming from within a comp. Hoppers, Kim persuaded Sandy to want to eat. Here it's coming from within two ex-comps that are embedded within one another. And then hoppers, Kim wanted Sandy to believe that the gorilla likes. These are two comps embedded within one another. So as I already said, these types of phenomena are known as long-distance dependencies, and there's a whole family of these type of phenomena. LFG is very well known for its solution for long-distance dependencies. It's a very effective and elegant solution. And I'll introduce it to you now with the example, using the examples that we had just now. There are many more complex examples that we could use, but this will serve to illustrate the basic technology. So what you do in LFG is you assume that there's a path between this item and wherever the object is licensing it. What you don't know when you're starting out here to the left is what this path will be. Hence, you talk about functional uncertainty. What you're saying is you do not know at the beginning where the path is going to take you. What you do is you specify possibilities and say, well, it could be any one of these possibilities. For example, here's a sample path for English, or in general for functional uncertainties. You could say, okay, I'm going to have either an object or a secondary object. It's going to be one of these. In the examples that we saw, subjects don't tend to be topicalized in that way. So either an object or a secondary object. And this object or secondary object could be coming from within either an XComp or a comp. So this is the disjunction. And there's a Kleene star here, which means there can be 0 instances of it, or infinitely many. Okay, so we're saying we don't know the level of embedding starting from here. We just know it could be XComps or comps, and you could define other things here if your language has other things as well. Okay, but this is the sort of standard uncertainty path that one has. So let's work with this path. What do you do once you've defined such a functional uncertainty path? Well, you annotate it on the relevant C structure node, and I've given you an example here. In this example, I've augmented our S rule, the one we've been working with. This part should be familiar to you. NP, VP. NP is the subject, VP is the verb phrase. And I've added this part. I've added an optional NP in front of the subject NP. And you might want to add a comma in here to make sure this is actually an extra NP and deal with the punctuation. I've also added an annotation that this is the topic. Usually when you get this type of long-distance dependencies, well, not usually, but often there is some kind of information structural phenomena involved. In this case, we'll call it topicalization, and we'll annotate that here. We'll say whatever this NP is the topic. And in addition, this NP is going to bear a grammatical function, either an object or a secondary object. We don't know which, one of these possibilities. And it could be embedded in any number or no or any number of XComps and comps. Okay, and this is what's establishing the long distance dependency. So let's see if this works out now. Let's take the simple example, Hoppers Kim likes. Okay, so we use our rule. We say Hoppers, this is this NP, it's the topic, followed by Kim, which is the subject, followed by a VP, which only contains this verb likes right now. Now, what do we know? So we know this is the subject. How do we figure out what this is? Well, it could be either an object or an object too. Likes doesn't subcategorize for an object too, it subcategorizes for an object, so we're going to pick this option. And then it could be in this kind of a path over here. But in fact, we don't have any XComps or comps. Like doesn't subcategorize for any of these. So we're going to choose the 0 option. We're just going to say this NP is a topic and it's also the object of my clause. And that'll work out. Okay, let's try a different example. Hoppers Kim wants Sandy to like, and I've told you what the XComp is here. Okay, so we've got wants as a verb. The subject of wants is Kim. Wants has an object, Sandy, and it has another argument, which is this XComp. And then we have to figure out what Hoppers is doing here. So we check. Wants has all its arguments satisfied. Sandy is the object, Kim is the subject, and it has an XComp, so it has no missing arguments. Let's go on. Like, The subject of like is Sandy via functional control from last time, if you remember that. But its object is missing, and I've notated that here with this underscore. So there's an object missing. Okay, so let's pick the object. And then what is the path down to there? Well, we have an xcomp. It's the object of the xcomp. So we're going to instantiate this part of the functional uncertainty path. We're going to say, okay, this thing is the topic, and it is also the object of the xcomp of the clause. And then that works out. Let's try another one. Hopper's Kim thinks that Sandy likes. Here we have thinks as the main verb. Thinks has a subject and a comp. So its arguments are saturated. It has both the arguments that it needs. Likes takes a subject, that's Sandy, and it takes an object which is missing in this clause. So we have that information, and we have the information that Hopper's here. Could be any of these things. It's going to be the object, that's what we're missing, and it's embedded in a comp. So our functional uncertainty path will be this. It'll be comp object, and that's what describes what the relationship of what the grammatical function of this is. It's an object of the sentence's comp. Okay, so that one works out well as well. Let's try another one. Hopper's Kim persuaded Sandy to want to eat. So here we have an xcomp embedded in an xcomp. Let's see how that works out. So again, persuaded has a subject, that's done. It has an object, that's done, and it takes an xcomp, that's done. Want takes a subject, that'll be Sandy via functional control, and an xcomp, that'll be to eat, so it's done. Eat has a subject, which is again Sandy via functional control, and an object that is missing. So when we look at Hopper's, we say, okay, it's going to be an object, and it's embedded in this case under two xcomps. So this is what our path will end up being. We'll say the Hopper's is the xcomp's object. And that's how that one works out. Another one. Hopper's Kim wanted Sandy to believe that the gorilla likes. So what do we have here? We have want, which has a subject and an object and an xcomp, so it has all its arguments there. Believe has a subject, which is Sandy via functional control, and it has a comp, so it is done. Likes has a subject, gorilla, and its object is missing. So again, we'll take this object option here, and then the object is embedded in a comp, which is again itself embedded in an xcomp. So our long distance dependency path will be xcomp comp object. Okay, and that's what we can get from this one. We can pick this one once, we can pick that one once, and then pick on the object. So, question, does the functional uncertainty path that we defined provide the right results for these examples? And the answer to that is yes, and we could try any more of these, and you will in fact implement these and see that you can embed as many comps, xcomps under one another, and you will be able to get the right result. Okay, so that was functional uncertainty, which is also actually more correctly known as outside-in functional uncertainty. This is the English topicalization data. Outside in, because what you're doing is you're saying, I am here, I belong to somewhere, let's look in here, do I belong here? No. Do I belong here? Yes. So you're looking from the outside in, you're saying xcomps, comps, object. But functional uncertainty paths can, in principle, also be defined from the inside out. And within LFG, this has been used for anaphora, for the reference resolution of pronouns and reflexives, and for constructive case. And the latter has actually been implemented in the Urdu Pargram grammar. The former has not been implemented. It's theoretically very well described, but it hasn't actually been implemented. And I'll show you an example of this now. First, I'll give you the definition. So functional uncertainty, what it does, it defines a search path, what I've been calling the long distance dependency path, over an attribute value matrix. In this case, this is our F structure, which is an attribute value matrix, if you recall that. And here are the definitions, the formal definitions of long distance dependencies. It was first invented in an article by Kaplan and Zanen for Germanic word order. And inside out was first used for an analysis of an afferent that was proposed by Mary Dalrymple. I'll give you these references as part of the exercise, so you can look them up if you're interested in that. Okay, now as an illustration, we have the sentence, Chris, we think that David likes, for example. Okay, this is exactly the kind of situation we had before. I've given you the C structure to the left and the F structure at the right. And what happens is that we say, okay, this likes is missing an object. Chris is up here. How do we figure out what the dependency is? Okay, in this case, I'll give you a simplified functional uncertainty path. I'll just say this is the topic, and the topic is equal to any number of comps and then the object. This is a subset of what we had before, just for illustrative purposes. So we'll say, okay, so I'm the topic here, Chris, pred Chris, this is the topic. And then we need to figure out what else it is. What else is it in the sentence? What grammatical relation is it? So you say, okay, I can go through any number of comps or an object. I can start by looking at 0 comps. Does this verb need an object? No. So that possibility is not the right one. Then I can try 1 comp. Okay, let's try 1 comp. Let me look down here into the comp and check if in here somebody needs an object. And in fact, likes does need an object. It hasn't been identified yet. So you can say, okay, then the topic of the clause is the comps object, and we can identify the two with one another. This is what this red arrow, this red line here is doing. Okay, so that's outside in functional uncertainty. Outside in because you're starting from the outside, saying I'm a topic, I need to find somebody inside this AVM somewhere. What's my search path over this AVM? Well, I could try comp, I could try an object, and then I find it in this case. But I could have a more complicated search path, as in the examples we had before. Now, in contrast, inside-out functional uncertainty, here's an example for that. David wrapped the blanket around himself. The problem here is that you want to figure out what himself is referring to. Okay, this is a reflexive pronoun. You can also do this for pronouns. I've chosen a reflexive pronoun because in English it tends to be subject-oriented. Pronouns, reflexives tend to be subject-oriented. So what you can say here is that in order to figure out what himself is referring to, is that we know from our English knowledge is that it needs to refer to David. But what you can say is that, well, I know that himself is going to refer to some subject. But again, like in the outside-in functional uncertainty, you don't necessarily know how far away the subject will be. There could be any number of things in here. So what you say is, I'm going to start out with my pronoun. That's what this pro is for. It's going to be in some grammatical function. I don't know which one. So GF here just stands for grammatical function. That could be object, secondary object, oblique, excomp, or subject in principle. In this case, it's an object. And then there could be a number of other types of grammatical functions, and I can search through, but I'll start from the inside this time. So I'll start here. Here's my reflexive pronoun, okay? And it says, okay, I need to start here and figure out who my antecedent is. Who am I referring to? So let's look outside. This is the first step. The grammatical function of the pronoun is an object. Okay, got that. Let's keep looking outside. Adjunct is over here, any kind of grammatical function. This is an adjunct, that works. And let's keep going until we hit the outside of the F structure, until we hit the top. And then look for a subject. And you find a subject, and so you know that David is the antecedent of this reflexive. Okay, so the major point here is that you could either have a search path going from the outside in, that was what we had with the topicalization example, or you could have a search path going from the inside out, trying to find something from within an embedded F structure and trying to figure out what grammatical function relates to it as you're working yourself through layers to the outside of the F structure. Inside-out functional uncertainty has been used for something called constructive case. As I said, it has been implemented in the Urdu grammar. We do case marking that way in the Urdu grammar. If you're interested in seeing code for this, you are welcome to contact me and I can share some code with you. Inside-out functional uncertainty is not trivial to implement. It's especially debugging it is non-trivial. However, it does work quite well. And we use it for situations like this. I'm giving you an example here from an Australian language called Wambaya. And Rachel Nordlinger articulated this quite well. And the examples are quite nice. So what you see in Wambaya is you have fairly free word orders so that even constituents can be split. So this sentence means the big dog bit me. Here's the verb, bite. Here is an auxiliary, which also has the me in it. And here's one part of the subject, dog. And here's another part of the subject, big. So how do you know in the sentence that big belongs to dog? Well, because both are marked with something called the ergative subject, which shows you that this is the subject. So you have a ni in both cases. Okay. So that says, so you have a ni in both cases saying that these are both of these parts describe the subject. And the way Rachel Nordlinger took this to be is that the case marker itself says, I know that whatever I'm in, it's the subject. So whatever I'm marking, it's the subject. And the same for over here. And then when you come up with the F structure, the case marker would be in here. It would say, I'm case ergative. I've left that out here for some reason. So case marking ergative would be in here, and it would say, I'm in here, and whatever is outside of me, that grammatical function, that is the subject. Okay, so this is also a case of inside-out functional uncertainty, whereby the case marker is saying, whatever grammatical function I'm marking is going to be the subject, and the case marker would be registered here. So this is exactly the kind of situation that we also implement in the Urdu grammar, where we let the case markers determine the grammatical functions of the language, of the noun phrases. And the reason we do this is because there is free word order in Urdu, so it's very hard to do it as in English via position. So in English, the little toy grammars that you've had have all assumed that the first thing in the clause generally has been the subject. We've now introduced a topic as well, but we've generally assumed that the first thing is a subject and that the immediately post-verbal item, the NP there, is the object. So English is known as an SVO language, and it has fairly fixed word order, not completely fixed as we saw, but fairly fixed. So we can use the positional information in English to determine what the grammatical functions are. However, many languages tend to be subject-object-verb, SOV languages. I think most of the languages of the world are actually SOV, and they tend to have fairly free word order. They allow scrambling. So you can't be sure, while SOV is the default word order, you cannot be sure that position will indicate what the subject is. The subject could be after the verb, it could be just before the verb, you don't know. What does tend to be helpful is case marking. And Urdu is one of such languages, which is why we've used the inside-out functional uncertainty method to deal with case marking there. So major constituents tend to be able to scramble in these kinds of languages. And the separation between C structure and F structure, just as an extra point, allows a very straightforward treatment of free word orders. So you can let things scramble at the C structure, but at the F structure you can keep what is going on in terms of subject, object, verb. That'll be very similar. Okay, and how do you actually deal with free word order in grammar implementations? Well, it's extremely simple. You use something called the shuffle operator, and you will be practicing with that in the exercise. The shuffle operator is extremely innocuous looking. It is simply represented by a comma. If you're looking through the grammar code, you might overlook it completely. It's represented by a comma, but it is an extremely powerful operator. It is used between items that are meant to shuffle among one another. I've given you an example here. So this would be a sample rule. I've left off the annotations. So we've got an S going to an NP, Kleene star meaning 0 or any number of NPs, a PP, 0 any number of PPs, and a VC, which stands for verbal complex. So this would be a verb plus its auxiliaries or complex predicates or what have you. And you can see the comma is here. So NP star, comma, PP star, comma. And what this results in is at least the following strings. Okay, and I've put 3 dots there because you can have all kinds of other strings. You could get a string like this, an MP followed by a PP followed by the verbal complex, starting with the verbal complex followed by a PP followed by an NP, 2 PPs in a row followed by an NP followed by the verbal complex followed by a noun phrase, an NP followed by the verbal complex, a PP, an NP, a PP, etc. Okay, so since I've got the Kleene star here, in principle, you can have as many strings as you would like. Now, I've been using the Kleene star here for purpose of illustration. Actually lets you say, if you know that a sentence is not going to have more than 4 NPs in it, it actually allows you to specify that. And I'll point you to where it, how to do that in the exercise. But for now, I've just used the star here, and the shuffle operator then will allow any of these strings to appear, to be generated. Okay, so an extremely powerful operator. Very innocuous looking, just the comma, but it allows you to deal with free word order in a very simple way. And I would like to emphasize this here again. There are many other grammar formalisms out there. A lot of them are still struggling with free word order. They tend to come from English, deal with English first, rely on positional information, and then struggle with dealing with free word order languages. Some other grammar formalisms have already resolved this. Some are still struggling with it. In LFG, this is a very simple approach to dealing with free word order, and one that works quite well. It has been implemented for Japanese, for Korean, for Urdu, for German, etc. Okay, so that actually already concludes lesson 9. I didn't do practical work with you today in the demo. There is practical work that you will do in exercise 9 that will, as I said, deal with the functional uncertainty path and with the shuffle operator. And then we will proceed on to lesson 10 in the next one, where I will give you further ideas of what to do with XLE. Okay, that's it.